All right. So again, we're going to be talking this morning about skimmer basin design for construction and post-construction. Each month that we do these, we try to focus a little bit on some different states and talk about the specifics for that state. This month, we're going to be looking at Texas, Louisiana, and Mississippi. If any of you are on here from any of those states or work in those states and I hear something or you hear something that's not quite right, please jump in. We try to stay up to date, but things do get updated sometimes. So we're not always aware. So I'm also going to, well, I'll do that 1 second. So again, did a quick introduction. My name's Jamie McCutchen. Again, principal and founder of Rymar Waterworks. A little bit about me. I'm a 92 grad at Clemson University. Go Tigers. Um, Hopefully we have some folks on here from Louisiana. We'll see, what kind of tigers are the best tigers here coming up in a week or two. Um, I founded CCAD Engineering in 1999, small civil engineering firm focused primarily on private development. Invented the Marlee float skimmer back in 2013 when South Carolina adopted requirements for skimmers. And I'm a licensed professional engineer, South Carolina, North Carolina, and Georgia. Give you that background just to say that hopefully this is a technical presentation intended to help, with your permitting and sediment basin design. And hopefully you'll find something useful that you can put into your practice today. At this time, I'm going to stop the video of myself just so it helps with the recording for the YouTube and website. So today what we're going to talk about is a introduction to skimmers or floating outlets and why we use skimmers. We're going to talk about the basics of skimmer basin design, some importance of some critical design criteria. Honestly, it's the feedback we get from MS4s about the things that they see done incorrectly most often. So we're going to try to help you avoid those. Then we're going to turn a little bit, talk about permanent use of skimmers for post-construction, some benefits and challenges of that. And then we're going to wrap up talking about the Rymar water quality filter, which is a new post-construction water quality product. And we'll tell you about it and kind of where we are in the testing and approval process of that. We will have a couple of polls as we go along here today. So the first one is, I get it to come up. How familiar are you with skimmers? This kind of just lets me know what our audience is. We've got, I think, probably maybe close to 60 or 70 folks signed up for this one. Got about 50 have joined so far. So if you could, when we do the polls, fill those in quickly and we'll, keep moving along. I'll wait for a few more to answer. All right, we got majority have done, so we'll end that and share. So it looks like we got about 15% that are new today. So welcome. Hopefully we found this very helpful. Majority of you, about 65%, somewhat, but need to learn more. So again, we're going to try to achieve that. And about 20% vary and have used them. So thanks for joining us as well. Hopefully I'll give you some information today as well. So for those that are not so familiar with them, what we have been doing in the past is a perforated riser. So we had a pond, we would draw it from the bottom of the pond. So we typically had some sort of check dam here to try to stop the sediment. But the discharge point was at the lowest point where the sediment accumulation is the highest. And what the result was where we're pulling water out of the basin at the point where the water is basically the dirtiest or has the most sediment content in it. So skimmers have been around now for about 25 years. They're fairly simple. They float on the surface. They withdraw water from the surface or near the surface, and they drain the pond from the top down. So what this does is it allows sediment to settle, gives more time for the sediment to settle, and releases that cleaner water from the surface first until it gets down to near the bottom of the surface. The Marlee float is a little bit different than most other skimmers in that our inlet is submerged. So we have a debris guard around our float. Water will come under that debris guard, in through the grate, and then out. And we do have a float system that makes sure it stays, fairly consistent level below the surface, but does not sink. There are a variety of skimmers on the market today. The Faircloth skimmer was the first one around. They've been around now about 25 years, pretty much pretty similar design to what they had when they first came out. Erosion Supply Company skimmer or ESC skimmer. It's kind of similar to the Faircloth, except it has little legs on it instead of a float. The IAS skimmer is a simple T model, and then you got the Marlee float, which obviously looks a little bit different. It's than the most other skimmers out there. I have seen a few other skimmers that are coming around. I'm not sure if they're really in practice much yet, but this is a evolving niche, and expect to see more on the market as the years go by. So just a little quick video to kind of show the effectiveness of the skimmer. So this is a site in Anderson, South Carolina. It's about 8 acres. It's an RV boat storage facility. At the time this video was taken, the site was fully disturbed. We have kind of red clay soils there. So this is the actual discharge from that sediment basin, and pretty clean water considering what was in there. One thing to note about the site is it's located about 100 yards from Lake Hartwell. And so the client was very concerned about getting complaints or turning the lake, red or brown. So we did have some flocculants out past this just to help a little bit with that. But based on the color of this water coming out, the skimmer was doing a very good job of releasing relatively clean water from that sediment basin. So, just kind of quick comparison, without a skimmer, again, you're withdrawing from the bottom. That's where the sediment load is the highest. Each time it rains, you're going to have some sediment resuspended. And so if you're withdrawing from the bottom, you tend to release more of that sediment. You're going to have the highest turbidity at the bottom where that sediment load is highest. Maintenance is going to be more. When you're down at the bottom of the basin, sediment's going to accumulate. It's going to take more maintenance to keep that flowing correctly. And sometimes you need a larger basin or at least more maintenance for that. However, with a skimmer, you're going to release that cleaner water from near the surface. You have better sediment retention because, again, you're releasing from the surface. So when sediment gets resuspended, it basically stays in the lower section of the pond. It doesn't necessarily float all the way up to the top. You can have less turbidity. Be honest, skimmers are not a turbidity reduction device. They do help just because you're releasing that cleaner water from the water column. But you may need flocculants if you have turbidity requirements. You do have minimal clogging and less maintenance. And in some cases, you might reduce the size of your basin. That's more of a post-construction thing than during construction. So there are 3 fundamentals of sediment basin design when it comes to sizing the skimmer. Number 1 is basin volume. So the basin volume is going to be the area based on the area flowing to the basin. States have different regulations on this. Some require you based on total area, some on disturbed area. What we typically see is either 1,800 or 3,600 cubic feet per acre flowing to the basin. Now, some areas also require the basins to have a permanent pool or sediment storage volume, and that area is not typically drained by the skimmer. So that's going to be below the invert of the skimmer, more of a permanent wet pond situation. The main thing here, when you're designing your skimmer, a lot of times your basin may turn into your post-construction detention pond. And when that happens, the volume for those ponds can be much larger than the volume required for your sediment basin. We really focus, if you take one thing away today, use the required volume, not the actual volume to size the skimmer. I'm just going to kind of pound that in and on this. And I'll give you an example of why that's so important. Number 2 is dewatering time. Again, sediment basins work by allowing time for sediment to settle to the bottom. The most common standard we see is a 2 to 5 day drain time. That does vary. Some states are 1 to 3. Some states are, as little as 10 hours. It does vary across the country. But the most common we see is 2 to 5 days. And then finally, flow rate. Once you know your volume and your dewatering time, you can then establish that flow rate, which is simply basin volume divided by dewatering time gives you that flow rate. We recommend that you use the range of time when you're doing your specifications. If you've got 2 to 5 days, come up with a flow rate for 2 days versus 5 days. And that will give you more flexibility when it comes to contractors wanting to maybe swap out a skimmer for one they already have. You don't have to go back through the review process because it's already been approved. So this is an example of why we really focus on required storage versus provided. So this is taken off a set of site plans. I think this was an engineer in Georgia I'm not going to say who the engineer was. They did spec us as the Marlee float. They had a time to drain of 72 hours. They specified an 8-inch skimmer. Again, the Marlee, they said there's sediment storage required, which in this case is actually dewatering volume, 1,754 cubic yards. That would actually need a 3-inch skimmer with a 2.5-inch orifice to drain in 72 hours. The provided volume of the pond was about 7,500 cubic yards. That would have needed an 8-inch skimmer with a 6.5-inch orifice to drain in 72 hours. You can see here I've got the price difference. So a 3-inch skimmer would be about $1,100, 8-inch skimmer about $5,900. So number one, by going on the larger volume, the contractor client's having to pay a good bit more for the skimmer. But more important, that 8-inch skimmer would drain that required volume in less than 9 hours. And so if your local regulation is a minimum of 24 or 48 hours, you're now non-compliant. And so your basin's not complying with the requirements. You're also going to be releasing more sediment than you really should because you're releasing water much faster out of that basin, not giving it the time to settle. So a good example of why we're focused on require storage versus provide. Okay. Excuse my cough today. I've been traveling and got a little dry throat, so I try not to cough much on you. Now we're going to talk about some state standards. So we're going to start with Texas. So Texas has just recently started enforcing these standards. They've actually been requiring skimmers, at least from a technical regulatory standpoint, since 2013. But this has just now kind of come into an enforcement. So in Texas, what they want you to do is calculate the volume based on a 2-year, 24-hour storm from each disturbed area. So not your total acreage, but just your disturbed area when you calculate that. If you can't calculate it for some reason, or rainfall data is not available, or something can't be done, they want you to provide a minimum of 3,600 cubic feet per acre drained until final stabilization of the site. And they do want you to use outlet structures that withdraw water from the surface. They want to do a minimum design dewatering time of 36 hours and no less than 72 hours. And they want that based on that 2-year, 24-hour storm. The basin's primary outlet and spillway shall be designed to carry a 25-year, 24-hour storm. So that's going to be your skimmer, your top of your riser, and your emergency spillway will be designed to handle the 25-year storm. They want you to withdraw water from the surface unless infeasible. And they also recognize that discharge rate for surface skimmers are dependent on the configuration of the skimmer, and they recommend you use the manufacturer's flow rate charts to select the skimmer based on the flow rate you need. We'll talk about the differences in some different skimmers and how they can vary, so you understand that a little bit better here shortly. They also have a design form. Again, total area, disturbed area, got your minimum required volume. On the design form, that actually says it's the lesser of 3,600 cubic feet or 2-year, 24-hour storm. So if your 2-year, 24-hour storm calculates to be more than 3,600 cubic feet per acre, you just use that 3,600 cubic feet per acre. So now jumping over into Louisiana. So if we have anybody here from Louisiana, let me know, because I've had trouble kind of finding much there. Louisiana put in the effective, construction general permit went into effect in October of 2019. And in that permit, they said for drainage locations that serve an area with 10 or more acres disturbed at one time, a separate sediment basin calculated for volume of a 2-year, 24-hour storm or 3,600 cubic feet is required. Again, if you've got smaller sediment basins, they still want you to do that. You can utilize smaller basins and break it up. They still want you to base it on a 2-year, 24-hour storm, 3,600 cubic feet per acre. I did not find in the Louisiana regs a time frame, at least not yet. So I would assume 2 to 5 days because that's kind of the general standard we see most often. But if someone has that information, let me know. They've got an urban stormwater runoff guide for BMP. It's got a little bit more guidance in there. Again, has sediment control for sediment basins and rock dams. But not a ton of information that I was able to find on Louisiana. So, so if got somebody from Louisiana on here, so yeah, I'd love to hear more information about that. So since we don't have much there, we're going to jump over to Mississippi. So Mississippi does have a erosion control, sediment control and stormwater management handbook. So they actually had 3 volumes, volume 1, 2, and 3. Volume 1 contains standards for sediment basins. So they do want you to use equipped with a floating skimmer for dewatering. Well, they kind of tell you why here, which is pretty interesting. Old technology utilized a perforated riser for dewatering, which allowed the water to leave from the basin in all depths and primarily the bottom. And one way to improve that sediment capture is to have an outlet that dewaters from the basin from the top of the water column where the water is cleanest. And skimmers are definitely the most common way to do that. There are a couple of other ways to do that that they include in their manual, but they're very labor intensive. You have to actually be on site and make some changes to them. So skimmers are definitely the easiest way to go. So they do specify dewatering time of 48 to 120 hours or 2 to 5 days. They also specify a minimum volume of 3,600 cubic feet per acre of drainage area. So that's the total area. They've got a minimum length to width ratio of 2 to 1. Dewatering with a skimmer, again, 2 to 5 day dewatering time. So, that's the basics. Mississippi does have a pretty good manual. It's about 24 pages, goes through a lot more detail. I'm not going to go through everything in there today, but if you're doing work in Mississippi, just check that out and make sure you're following those criteria. So as we talk about that, I'd love to know where our group is located today. So I'm going to launch another poll here. If you could just let me know where you're based. And if your state's not on here, just click the other. And if you would throw into chat where you are. I'll give just a second for everybody to enter that. I just kind of make sure we keep people engaged as well. So got a couple from Minnesota, but work in Texas. We're going to do, for those of you in Minnesota, we're going to do Minnesota next month. I did notice we had a good many from Minnesota signed up. We're also going to talk about West Virginia. Looks like we got a Washington. Welcome. I'd love to know in Washington if you're using skimmers because so far we have not seen many there. So anyway, I'm going to end the poll. Looks like I have a really broad range this month. So Texas is number 2 with 6 people. Ohio is number 1 with 8 people. And then, 1 or 2 from a lot of different places. So didn't share that. So there we go. And then other wins with 20. And so we're looking at these and we saw Nebraska as well. We'll try to cover Nebraska in the next month or so as well. All right, keep moving along here. So, just have a couple of different standards up here just to show you how it does vary. So I've got Mississippi, Texas, Louisiana, we're talking about today, and then I threw in Ohio for comparison. So basin volume, Mississippi, Texas, Louisiana, all are in that 3,600 cubic feet per acre or calculating the 2-year 24-hour storm. Ohio is 1,800 cubic feet per acre, plus they require an additional 1,000 cubic feet of disturbed sediment storage. So again, that area is not drained by the skimmer, so not included. Surface area, some have formulas, some have minimum length to width ratio, some have max depths. Principal spillway can vary, 2-year to 10-year storm. Mississippi is actually a 25-year and didn't fill that in. Emergency spillway, 10-year, 25-year storm. Where is the skimmer required? Some places it's 5 acres or more, some places it's 10 acres, some of them is any sediment basin. And then again, dewatering time, 2 to 5 days in Mississippi, Texas, 36 to 72 hours, Louisiana. I found somewhere 48 hours, within 40, want to drain fairly quick, probably because you get a lot of storm events back to back there. And then Ohio is 2 to 7 days. So, and we'll show you here in a few minutes where you can find more information if you're an engineer. So several engineers that say they live in one state but work in others. So we'll show you a tool we developed to help you with that. So why do we specify or harp on specifying flow rates, not skimmer size? Skimmers are thought of as constant head, constant flow devices, right? They just kind of sit and float, so that head doesn't change much. However, testing has shown that all skimmers have a flow rate curve. So this chart here was taken from some work that TRI Environmental did for Georgia when they were updating their erosion control manual. They tested 3 different types of skimmers. They don't name who they are manufacturers wise, but got type 2, type 1, type 3. All 3 of these are 3-inch skimmers. Their test tank is 4 feet deep. And you can see at 1 foot of depth, 2 of them are very close in flow rate. They're about 37 GPM. Type 3 here is nearly double at 70 GPM. As you go from 1 foot to 4 feet, there's an increase of about 25% in the flow rate. 2 of them, again, are pretty close, right around 50 GPM, and one, again, is nearly double at 90 GPM. So if you just specified 3-inch skimmer and you didn't give any other information, and you intended for one to flow slow and got to fast, or vice versa, your site's probably going to be out of compliance. So it's very important to give information on the plans that can determine what that flow rate is. At least give the required volume and time frame. That way, a contractor says, "Hey, I want to use this skimmer. Does it work?" They can run the calculations to make sure they've got the proper orifice size with that. So kind of going back over here, we got what we call our skimmer design formula. So number 1, calculate that required basin volume, drainage area times that regulatory requirement. So for example, we had a 5-acre site and it was in Ohio, it'd be 1,800 cubic feet per acre, so 9,000 cubic feet. Step 2 is determine that dewatering time. Again, standards typically 2 to 5 days, but you got to check your local regulations. Step 3, calculate that flow rate. Again, we recommend you calculate that range. So 2 days, 4,500 cubic feet per day, 5 days, 1,900 cubic feet per day. And then select that skimmer size. So match it to the flow rate charts, whether you use Marlee Float or others, or, pretty much most skimmer manufacturers have design aids out there for you. Speaking of, we have 2 different design aids for you. We have an Excel tool that you can download. So this is pretty simple. You can put in your date, project name, location, your company information. We have this little check right here. So you put in your area to the basin and that required volume. That's going to come up with your required volume per acre. That's going to tell you your required volume for that basin. So in this case, 13,500 cubic feet. Basin description, got 2 other things here. Sometimes you have like a phase 1, phase 2, phase 3, whatever. Things may change a little bit as far as area to the basin. Here you put in your min and max time to drain. So we got 120 to 48 hours or 2 to 5 days. Pond depth. Now that pond depth is not the total pond depth. That pond depth is the depth required to meet the required dewatering volume. So if your pond is 6 feet deep, but you meet your required volume at 3 feet, just put in 3. So your top length and width and bottom length and width. I know there's very few square or rectangular basins out there. So just use a reasonable number here. Try to get this calculated pond volume within about 5% of that required volume. Okay. Once you do that, this spreadsheet is going to show you, oops, a little faster here. The spreadsheet is going to show you the calculations for each of our skimmers with each orifice size in it. You're going to go down here to the skimmer report page tab, click on it, take you to another sheet. It'll be a nice, neat 8.5 by 11. The top of the sheet is going to have all the information you put in. It's going to have this little check right here so the reviewer can see, yes, my required volume and my calculated volume I'm basing the skimmer on are very close. Here's my minimum and maximum flow rates based on the maximum and minimum time. And then because it is our tool, it's going to tell you each of our skimmers that falls within that allowable range of time and is acceptable for the site. So in this case, I would probably use our 2-inch skimmer with a 2-inch orifice, drain the pond in about 69 hours, so right at 3 days. It's going to be the least expensive skimmer to kind of meet the specs there. If you want to drain it faster, you go to 48 hours, you can go up to our 4-inch skimmer with a 2-inch orifice, drain right in 48. If it's a really high silt clay and you want to do as long as possible, you can go out to 111 hours. But anyway, this is where the engineering preference comes in, whichever one you prefer. So we also have some details. We've developed these details looking at multiple states. So we try to make them one size fits all as best we can. They are available in CAD as well as PDF, so you can edit them as needed. Up here, you're going to have a design data block. So this will apply to all the basins on the site. So you may have a minimum or max length to width ratio. You've got your volume required, your surface area required if you have one. Here's where you set your min and max dewatering time. So that's going to apply to all the basins on the site. Down here, you're going to have a data block for each basin. So you can expand this as needed if you got, more basins on the property. Basin number, drainage area, disturbed acre, your Q, flow rate, basin volume. Again, you want to make sure your provided is at least what's required. Surface area, if you have that requirement. Outlet invert, barrel, top risers, blah, 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 versus spillway width, etc. Here's where you get into your skimmers. You've got a skimmer size, skimmer orifice diameter. Most skimmers now use the orifice diameter with their skimmer manufacturer. This may come filled in with Marlee for you or Rymar. Equal is allowed, yes or no. Most of the time, that's a yes, not always. There may be some situations where you only want to use the specified skimmer because you have a very tight flow rate or some other reason. And then what's your skimmer flow rate and range, your min and max? So if you got this filled in, say you allowed an equal yes, and the contractor came back and said, hey, I've got the skimmer left over from this other project. Can I use it on this basin? As long as they can find the manufacturer information to show that it can fall within that min and max flow rate, then yes, that's approved. Simple shop drawing, very, very quick check. You don't have to go back through a full review. If you had specified an exact, 3-day time frame or exact whatever hour time frame, then it's maybe very hard to find another skimmer that's going to hit that exact time frame. So that might require additional review, going back through something. So it kind of depends on where you are, what the regulations are looking at, how your inspectors are looking. But that's why we recommend that range. So it gives you a little more flexibility if you do need to make a change in the field. This is our standard detail. A couple of quick things about it. Standard detail includes the flow rate for each skimmer or in each orifice configuration for that skimmer. It gives the flow rate at 0.1, 0.3, and then every half a foot up to 4 feet. We use what we call an orifice plate. This goes inside the skimmer, so we've got a grate, and then right here, there's an orifice plate that reduces that hole, in the of the outlet, going to the pipe. Very simple. We'll have a little video about that here at the end. The most common question we get is the length of pipe needed here. So we recommend that this length of pipe be 1.4 to 1.5 times the height of your riser. What this does is it allows the pipe to be at about a 45-degree angle when the pond is basically full and skimmers floating at the top of the riser. This seems to be a pretty common industry standard, so pretty well accepted. We would also recommend probably a minimum 6 or 8 feet of pipe. If you have a really shallow pond, the riser is only 2 feet tall, you probably want more than 3 feet of pipe out there. So we would probably go with 6 or 8 feet. So we also have a skimmer calculator on our website. I'm going to switch over to actually run a true example. So here's our website. If you go to Marlee Float and the sizing calculator, pop up for you. All right. Now you can enter your basin name. So for example, I'm just going to put A here. We have the state drop-down box. So you go here, let's just say you're in Ohio, but you're working in Texas. We'll pick Texas because we're talking about Texas today. When you pick that drop-down box, it's going to fill in your required cubic feet per acre. It's also going to fill in your min and max time to drain. Okay, we do this as a kind of service, to you. Please, if you see something that's wrong, if this, we can't guarantee this thing is 100% accurate, but we do our best. Do that. So once you have that, if you know how many acres are going to your pond, just enter that. So let's just say we got 15 acres going to this pond. It'll do the required pond volume here, give you your min and max flow rates, and then you scroll down, it'll tell you which of our skimmers meet that time frame for that volume. And so in this case, you got 4 different skimmers. It tells you the drain time for each. So in Texas, we've got 1.5 to 3 days. So you can just pick. If you want to try to hit that 2-day time frame, our 6-inch with a 4-inch orifice hits about 1.9 days. If you're like, hey, I want to drain this, a little bit faster, our 4-inch with a 4-inch orifice actually drains a little faster than the 6-inch. Again, that's based on testing. That may be a little counterintuitive, but it's all based on testing. And so if you hit over here to the PDF or image file, click on that, it'll take you to a nice, neat detail. You can hit save, download that. It's got the information up top. It's got that skimmer flow rate, the drain time, what that required pond volume is, and what the allowable drain time is. So you can use that information if a contractor wants to do an equal, but it's got everything you need to do your detail. So engineers have found this very useful, gotten really good feedback on that. So we hopefully you find that to be helpful, especially this drop down box. We've got, not every state has requirements out there. So if you're working in a state and we're missing yours, let us know. We'll add it. I know we saw some Minnesota folks on here, so 1,800 cubic feet in 2 to 5 days. If you do see any error on there, please let us know. We try to keep it accurate as possible. So, all right. So that's really kind of wrapping up skimmers for sediment basins during construction. Anybody has any questions on that, feel free to put it in the chat. We've got a pretty decent group, about 60 people today. So if you want to unmute and ask, you can, but probably better to save that to the end. We'll have some time for questions. So, all right. Don't see any questions in the chat. So we're going to move on to permanent use of skimmers. So we'll start here again with one of our polls. So we'll launch this one. So just simply, have you ever considered or have you ever used a skimmer for permanent use? While that's being filled in, Jordan, I'd be glad to answer that question. Common issues with installation. We don't have too many issues with installation. Installation of our skimmer is really simple. It's really a couple of worm clamps and just a standard PVC coupling. We provide instructions. We actually provide them in English and Spanish now. We also provide a sticker with a QR code on our in the poll here, share those. I'm talking about this with an installation video. So if somebody has an installation issue, they didn't try very hard. So just to be honest, but if you do have something, please let us know. We'll be happy. We work with contractors all the time if they have something come up, a special situation. So, but kind of getting back to the poll, looks like majority have not considered. So hopefully you'll find this next section very interesting. And 6 have considered and 6 have actually used. And I can't tell you how excited we are to see that yes go up each month. This is really something we've been pushing, and hopefully this next section here, for those that said no, will help you understand why. All right, so we're going to focus on dry detention basins. Okay, I know there's wet basins, there's extended detention, there's all kinds of other BMPs out there, but the dry detention basin is probably the most common BMP, across the country. And so when you have a dry detention basin, a lot of them, this is actually a pretty good looking basin, pretty well maintained, grass bottom, flowing down to an outlet structure. So, what typically happens post construction is that skimmer is removed. You put a low flow orifice down here at the bottom. Most places now are doing water quality, and water quality is often based on that first flush volume, that first anywhere from 1/2 inch to 1.5 or 2.5 inches of runoff, depending on what your local regs are, that you're trying to control with that low flow first flush orifice. And then you're going to do some sort of guard or filter to try to reduce clogging. So we've seen, all kinds of screens, guards, French drains, reverse flow type pipes, numerous things here to try to keep this from clogging. So if you were to look at a storm event, water coming in here on the left side, going out on the right side, get a pretty heavy sediment load coming in, that suspended sediment. As the water flows from inlet to outlet, that sediment is going to settle. You're going to have that high sediment load down here at the bottom, which would be where your orifice is. You're going to be discharging the height from the highest sediment load, but you've got the cleanest water up here at the top. And so if you could release this water instead of this water and drain the pond from the top down, your basin is going to be much more effective in trapping that sediment, which is what we're intending to do, right? The whole purpose of these sediment or detention basins is to trap those pollutants, typically using some sort of settling component to do so. So like we talked about, basins rely upon natural settling the sediment particles. We've already established skimmers release that cleaner water from the surface. They are widely accepted for construction. They've proven to be very cost-effective item. one of the few things that I can say from a new regulation standpoint has actually maybe reduced cost versus the old way. So why doesn't it make sense to use that same method for post-construction water quality? So give you a little case study here. So this is a pond. Yep, looks like a pond. It was a former car dealership. In 2013, they received a notice of violation for failure to maintain the pond. Right, shocker. The pond was obviously severely overgrown and the outlet structure was not functioning properly. So we helped the client here. We got someone to go in and actually cut the timber. I mean, we're talking, anywhere from 4 to I think 6, 8-inch trees in this thing. It had been left untouched for probably 15 or 20 years. This is what it looked like. Whenever it rained, it was holding water. We could see orifices here. We couldn't see any kind of low flow orifice at the bottom of the pond. So after doing some work, we figured out that there was about 6 feet of accumulated muck in the bottom of this pond. You can see here, these side slopes are pretty steep. They're about 1.5 to 1. Got a huge inlet coming in, got a lot of offsite water coming in, another couple of smaller inlets coming in. So we talked to the county and we got them to agree to let us redesign the pond, and we installed a skimmer instead of this. Used to be a 2-inch orifice down at the bottom of this basin. And again, these riser sections are about 6 feet tall. So muck and debris had accumulated 6 feet in the bottom of this pond. So instead of going in and cleaning all that out, we determined this pond was one of the rare ponds that actually had some excess volume available. So we closed in these old orifices, we put in new ones, put in the skimmer. Well, in this location, a skimmer had never been used for post-construction before. So the county said, hey, we're going to let you do it, but only under our pilot program. And you're going to have to monitor this monthly for the first year and then quarterly for the next couple of years. Make sure this thing works because, we don't know about skimmers for post-construction. We're used to these little outlets. So we did that, looked like that once it kind of got stabilized. Again, we had to do monthly monitoring. So these photos are from those monitoring. So it was working great. Everything's working just like it should. Skimmer's doing a great job of acting as that low flow orifice. So then the owner decided to get a contractor to do some maintenance. So they picked a bad day. They cut the sides of the pond. They let everything drop down to the bottom, and we got a huge rain, about 5-inch rainfall, dumped massive amount of water in that pond, washed all that debris down here to the bottom. You could imagine if that was a little 2-inch orifice there with all that debris, it would have absolutely been clogged up. And it's kind of hard to tell here, but like I said, these are 6-foot riser sections. So there's probably 7 feet or so from that orifice to there. So if that was clogged, you'd have 7 feet of water, that much debris. Getting to that would be extremely difficult and hazardous. So, even if the skimmer had clogged up, it's floating, get to it pretty easily, shake it around, unclog it, get the pond to drain. So from a maintenance standpoint, skimmers are much more effective than those low flow orifices. And you get the added benefit of releasing that cleaner water from the surface, so you're enhancing your water quality. So if you're going to consider a skimmer, right, and you're doing it post-construction, we've got to know how to model it with our, in HydroFlow or whatever program we're using. HydroFlow seems to be the most common stormwater hydrology program out there now because it's built into Civil 3D. Most of you are using probably AutoCAD Civil 3D for your design. So we're going to talk about it. If you use a different software, reach out to me. I'd be glad to help you on how to do it if there's questions. So first thing you're going to do when you build your basin, when you put your stage storage in, you're going to put in each stage to be able to enter that flow rate that we have. So here we got 0, 0.1, 0.3, up to 4 feet deep. This pond just happened to be 4 feet deep, so it kind of worked out. You can take the flow rate directly off the skimmer to fill that in. So when you go to build your outlet structure, you're going to have a orifice or a culvert going out, so your barrel going out. So in this case, it's a 18-inch pipe going out of the pond. Got one barrel, here's our invert, length, slope, etc. This is in an area where they require quantity control during construction. So this is a pretty complicated outlet structure for a small basin, but had a 6-inch orifice about 1.75 feet above the bottom of the pond. A riser structure was about 3.6 feet tall. and had a 1 foot rectangular weir in the top of it. And here's the secret sauce to this. Oops, catch up. Is this user-defined column. So this user-defined column is where you plug in your flow rate from your skimmer. So you've got your stage here, come across, plug in your user-defined flow rate off the detail. All right, pretty simple to do that. Now, but what happens if your pond's over 4 feet deep? You've got a couple of different options. If it's only like 5 or 6 feet deep, you can extrapolate it out. You can just kind of maintain that flow rate. Flow rate curves typically settle out for most skimmers around 4 feet. But let's say it's 8 or 10 feet deep. What do? We recommend you go back, use that Excel tool we talked about, and put in your full pond depth here. So I put in 8 feet as my pond depth. Okay. Now it's going to break that 8 feet up into 20 different increments. And it's going to give the flow rate at each increment there. So using this, you can build, plug in that flow rate based on that. So at a 4 foot depth, 6-inch skimmer with a 6-inch orifice, about 0.78 CFS. Gets up to 8 feet deep, it's about 0.86. So pretty minor increase, 0.1, less than 0.1 CFS. But depending on where you're located, how strict that reviewer is, that 0.1, 0.2 CFS can really matter when it comes to your pre-post hydrology calculation. So if you want to be as accurate as possible, we recommend you utilize this tool to plug that in. When you go back to HydroFlow, you look at your schematic, you're going to see it looks something like this. Normally, you'd have a low flow orifice down here, maybe a 2 or 3-inch orifice down here. In this case, we don't have that. We've got our 6-inch orifice, our weir, our riser. But you look at your stage discharge, that is your skimmer flow. So you can see your skimmer is flowing at those lower stages, then your other orifices kick in. So real simple, quick version of how to model in HydroFlow. We do have some more detailed instructional videos on our website we'll talk about here at the end. All right, so last thing we want to talk about today is our filtration-based water quality. So, Brandon, I got your question. I'll come back to you here just a little bit on that, okay? So filtration-based water quality. So like we talked about, most water quality is first flush. So you kind of detain a volume and release it slowly. We have developed a filter to go around our skimmer, and it is designed for the skimmer to pull water through the filter. So we take out the sediment particles that way. The filter is open on the bottom. So these skirts hang anywhere from 2 to 3 feet deep, depending on the size of the skimmer. That top 2 or 3 feet is treated by the filter. If it's over that depth, water can come below, but there's not enough turbulent force, not enough flow force to pull that sediment particle back up to the skimmer. So it's kind of a combination filtration, gravity device to do water quality. Okay. We have tested this to a ASTM standard. We'll go into detail on that. And we got 90% TSS removal using this method of skimmer with filter. So this took a while to develop. So we had multiple prototypes that we worked on over several years. This was the prototype we finally settled on. It was a turbidity curtain here on the outside with another fabric here on the inside. The turbidity curtain here you can see had basically polyethylene, woven fabric in it to allow flow through it. This gray material is a non-woven called Adsorbate. When we did our testing, although this material was rated to have a flow rate of about 125 gallons per minute per square foot, the skimmer didn't have the force needed to pull water through there. And so we realized that was an issue. So what we did is we decided to put 2 layers of this fabric. We cut 6-inch slits or panels in it, and we offset those panels by 3 inches. So what we created was water flowing, kind of weaving through that fabric, creating much more contact time with the water. And it was very effective as kind of a polishing method, to take out the smaller particles that got through the outer filter. One interesting thing that happened during the spring and summer is vegetation started to grow in that inner fabric. So like I said, it was really good at, capturing particles coming through. So we had a nice little green blob. At first, we were kind of worried that, hey, it's a dry basin. The material might root in the bottom and hold the skimmer down or hold the filter down. That never happened. So now we're exploring the potential for maybe floating wetlands around this to add to our nutrient removal. Again, we did this, we monitored it for over 2 years. We had a time-lapse camera set up to kind of watch things, make sure it was working right. You can see in this photo, turbidity in the main pond is much higher than the turbidity at the skimmer, once it comes through the filter. And this is the outlet here. Pretty clean water. I definitely wouldn't drink it. No one was going in that basin, but compared to what's coming in, this is really clean going out. So we got it tested, and we got a 90%, I said 90% TSS removal when we did our testing. So, there's lots of ways to test things. So, you can kind of fabricate results, depending on your testing. We used a ASTM standard. So a lot of people are not aware that ASTM now has standards for sediment retention or stormwater devices. So we hired TRI Environmental, a well-known third party, just happened to have a lab near us. ASTM is C1746, so it's a standard test method. This establishes your soil gradation. I mean, we're having to test really, really fine powder type. It's almost like flour type material. Okay, so we're not dumping 1,000 pounds of gravel in there and saying, hey, we got 90%. This is really fine material. The other thing we did was, with your typical dry detention basin, you have a forebay. You've got travel distance. You may have vegetation. You got a variety of things that are going to affect the sediment removal of that pond. There's no way for us to know how much of the removal came from each of those different things. So what we did was we created a worst case scenario. We modeled this as a dry basin. We had the water come here, you can see on the right side, about 1.5 or 2 feet from our outer filter. So there's no travel time. It's going straight from here to there. And so we modeled this as an absolute worst case, feeling that if we were able to achieve the results there, then in the real world, in a real pond, we're very confident that this will be, very successful in treating the stormwater. So we now have put our commercial version back in this same basin. So that's another picture of that basin. You can see it here. So we've got the outer material, like I said, is just a woven polyethylene, geotextile. And again, the inner is that non-woven material. It's called adsorbate. So we're monitoring that again. This is a little short video. So we had beavers invade this pond, unfortunately. They started building a dam around the outlet structure. But fortunately, they did not impact the skimmer, at least for several months. I'll be honest, about 6 months into this, the owner had not hired anybody to get rid of the beavers yet. So the beavers decided they wanted to gnaw on some geotextile fabric and some foam. And so we've now taken our filter out, but the skimmers continue to work. They've only occasionally been able to get the skimmer clogged. And that's really more just the huge amount of debris and not having the filter around it anymore. But it floats, really easy to get to, got a rope tied to it. So the skimmer is still designed to slowly drain that basin. We're not really taking, the filter is just an added benefit at this point. So let's talk about why you would want to use filtration versus settlement. So this, just in general, if you use filter, your peak rate of discharge can be based on your filter treatment flow rate up to whatever that first quantity storm event is, if you're using it in a pond. So this is going to reduce your pond size by 15%. I run some calculations, see as much as 30 to 40% pond size reduction. Why is this? Because first flush method, you're having to capture that first, whatever, inch and a half, hold it 24, some places 48 hours or more, that you've got to hold that volume and release it very slowly. That greatly increases your pond size. If you're using the filtration-based method, you can release that water faster. You don't have to hold that first flush. Typically, your first quantity storm event is going to be your 2-year storm. So you can put a skimmer in there that can release a flow rate close to the 2-year storm. It's going to let that water quality volume out much faster. That's going to greatly reduce the size of your pond. The other benefit here is the filter is going to treat 100% of that runoff up to whatever the peak rate of the filter is. So, using the first flush method, it's accepted. But what happens when you have, say, a 1/4 inch of rain that comes in over 4 hours. How much ponding are you going to get in that pond? That slow trickle is going to be enough to wash off the pollutants on most parking lots and other areas. It's going to go in the pond, but it's going to go in so slow that you're not going to get any ponding. It's basically going to go in, go straight out. And if all your treatment's based on settlement, that requires ponding. So you're not treating those low flow trickle events. With a filter, that flow has to go through the filter to get out. So it's getting treated. Now, on the flip side, if you design your filter to handle up to a 2-year storm event, now you're treating all the way up to your 2-year storm, not just that 1.5, maybe 2-inch storm event. That's your water quality event. You're now treating up to maybe a 3.5 or 4-inch event that would be your 2-year storm. And then the other benefit is your media can be customized to target specific pollutants of concern. I didn't mention this earlier, but the adsorbent material that we use for our inner filter, it absorbs hydrocarbons. It's been tested to help with metals. There may be some potential for nutrients. We haven't gotten there yet. We're going to be testing for that in the future. But you can put other materials in there. Like I said, we're working on some options to combine our skimmer and filter with maybe some floating wetlands or some other type materials that are nutrient removal. All right, some additional benefits are if you're using this in a pond, you've got a very large containment volume. So you're going to reduce that maintenance frequency and you're going to treat larger drainage areas and you're not going to have to maintain it for years. There are obviously stormwater filter devices already out there. They're typically maybe used in a catch basin, used in some kind of a vault. But when you do that, you've got a very limited volume to contain material. So if your filter is effective and it's really trapping much sediment, you're going to fill those things up and have to treat them much more often. So, but by using a pond, you've got a much larger containment volume. This is a huge one. This is kind of where we really are excited about is there's excellent potential to go retrofit older basins that did not include water quality when they were designed, if your peak flow rate can be maintained. So, if any of you have done redevelopment, say you got a shopping center and it's got a pond in it that was designed back in, the 80s or maybe 90s, depending on where you are, and doesn't have water quality. It's just got detention. And they decided to tear down a Dairy Queen and put in a Chick-fil-A. Okay. Um, you know, most areas are using that to trigger water quality for that redevelopment. Now you can go in and you can put in 6 catch basins around the Chick-fil-A and do water quality just for the Chick-fil-A. Or if you can go to your pond and you can put in a filter device that lets you maintain the existing flow rates so you don't have to change the volume of the pond. Now you're treating the entire site and you're doing it more cost effectively than trying to treat your little 1 acre, 1.5 acre out parcel. And then filters and ponds can be relatively easy to access and maintain, especially when you compare them to systems that are underground vaults or require confined space entry. Catch basin filters, they can be effective, but they're a lot of maintenance and they're kind of out of sight, out of mind. So a lot of times they get really filled up and really in need of maintenance. So same thing for vault systems. Now, if we take this a step further and we say, okay, well, let's look at using a skimmer with the filters. Now we're going to attach the filter around the skimmer. So what does that do for us? So now you've got a flow control device. Your skimmer can control the peak rate of those lower storm events, just like we talked about modeling in HydroFlow. The skimmer is going to increase the filter efficiency because now you're trying to treat that cleaner water into the surface. We could put a filter down here on the bottom. We could take a French drain and wrap it in a filter, have that. What's going to happen? That's going to get covered up nearly immediately with sediment if it's effective, right? Because it's down at the bottom of the pond. By having it here where it's up top, your filter is having to not work near as hard and it's going to be much more efficient. And then it's going to make it even easier to access. If it's a dry pond drains down, dries down, walk out to it, get to it, no problem. If it's a wet pond, tie a rope to it, pull it over, easy to get to and maintain. So there are some challenges to using skimmers with filtration. It's not a perfect system. Like anything that's going to require maintenance. There's not any or very few, maybe one BMP that I'm aware of that doesn't require much maintenance. But filters are going to be prone to clog over time, and they're going to require maintenance and periodic cleaning or changing. We monitored ours for 2 years and they were working. So right now we're recommending a 2-year time frame. Even the site that the beavers invaded, that filter had been out there for 2 years and was working great until the beavers attacked it. So we're comfortable with it lasting at least 2 years. Um, Skimmer, it's got to be durable. It's got to last them more than a few years to be suitable for permanent use. We would not recommend using Schedule 40 PVC skimmer for doing permanent, pond maintenance. You've got our product's HTP product, and it's going to be 20 to 50-year life. This last one is probably our biggest challenge, and hopefully there's some MS4 folks on here today. There are no established standards for basis design and permitting to combine a pond and a filter. If you've got that in your design manual, I'd love to see it. Most design manuals now have some sort of provisions for mechanical treatment device, MTD, proprietary products, whatever they may want to call it. So you got to work through that. We are actually actively testing right now for NJCAP. So we've got TRI Environmental doing testing so we can submit our skimmer filter product to NJCAP. Hopefully we'll have that testing completed in the next probably 2 weeks, and then probably take us 60 to 90 days to get through the NJCAP process. So we're really excited about getting that completed. The other thing I'll mention, because we do have some folks from Northern, we got Minnesota, Ohio. If you're in an area that has extended frozen conditions, this may not be the best product for you. It's probably going to hold up, it's probably going to work, but if you've got 6 inches, a foot of ice out there for several months, a product that relies on surface withdrawal may not be suitable. So just factor that in, to your sites. Probably once you get down into southern Ohio and below, you're probably pretty good. If you had limited, a couple of days of frozen, no big deal. But anyway. So just a little quick, as we wrap up here, a little quick example of a 5-acre site where we're using the first flush method. And so first flush method, we're releasing that flow on a 5-acre site at about 0.25 CFS. Need a storage of about 0.245 acre feet. Using the filtration method, going up to that 0.7 CFS, almost triple the flow rate. We've reduced our storage to 0.174. So 30% less volume between, a first flush method versus filtration method. And the filter has been proven to get 90% TSS removal. Now, you're treating up to your 2-year storm event. So last poll here, now that you're aware of the benefits of skimmers for permanent use, what are your thoughts? Maybe yes, no, love to just kind of get your feel on it. So majority are saying maybe, and we agree with you. I don't think this is necessarily the best for every site. It's definitely, going to be another tool in your toolbox. I'm still waiting for at least one no. I almost always get at least one no, but so far this group, no no's. So I'm going to end the poll before somebody jumps in and does that. So share the results. So we had nobody said no, which is exciting. Usually we have at least one or two. Majority said maybe. We agree with you. It's not going to be every single site, but I think it's a great tool in the toolbox for use. And same for you guys that said yes. We know that it's not for every site. So. All right, got just a couple of minutes here. I'm going to wrap up. Last part of here is just talking about Rymar. So this is our website. Went to it earlier. We do have a page on there. This webinar will be on that probably tomorrow. We usually keep 5 or 6 months worth on there. We also have a YouTube channel, which all of ours are there. We have a training series. So we take a deeper dive into things we talked about today, little 5 to 15-minute segments. We also talk about some things we didn't talk about today. So those of you, if you're in West Virginia or South Carolina and use SEDCAD for sedimentology, we've got how to model a skimmer in SEDCAD. Anyway, got several other tools out there. So just check those out. For engineers, if you want to download our spec pack, just go to our website, download the spec pack. It'll give a zip file. It's 3 separate folders. We have a Marlee float skimmer details, design tool, test data. we have the sediment basin details, and we have our water quality filter details in 3 different folders. So really easy to organize. Um, and then, why would you choose the Marlee float over others? Okay. Kind of toot our own horn just for a minute here. Number one, it's HDPE product versus PVC. So it's much more UV resistant, much more durable. Our flow rate, all of ours include that orifice plate, super easy to adjust. Others may be a little more limited flexibility and more difficult to adjust. Maintenance, we're less prone to clog than most other skimmers because of that debris guard and taking water in from just below the surface. All of our flow rates have been third-party tested, and we publish those. You don't have to ask. They're there in the information we provide. You can find it very easily. We're approved by all DOTs that we're aware of and accepted by all state agencies. If you have a DOT or state that says the Marlee float is not, please let us know. We'll jump through the hoops to make sure they are. But I know some DOTs now are starting to put in QPLs for skimmers. Not many do though. And then for post-construction use, we've had skimmers out on sites. We've only been around now for 13 years, but we've got skimmers that have been on sites for probably 12 years, still functioning, still working, doing like they were planned to do. So others, less evidence of that. Honestly, I'm not really familiar with any others that have been used permanently for that period of time. We talked about our orifice plates. A little quick video here. That's next to last slide, just to show you this. So that's it. Take the piece of rubber out, spin it around. Got this little metal nub here that helps center it and make sure that the orifice is completely centered on that pipe going out. And then I want you to notice here what it is to close it up. It's tool free, so 2 little clips. If you're an inspector, contractor, you don't need a screwdriver. You don't need anything to go out and check that. We do have 6 different skimmer sizes. One thing to point out, we have 2 different 8-inch skimmers. Our standard 8-inch has a flow rate up to 1.5 CFS. That's about 0.5 CFS over most other standard 8-inch skimmers. Our 8-inch with 8-inch pipe or 8-inch max has a flow rate of almost 2 CFS. Our standard 8-inch uses a 6-inch pipe to connect to the outlet. Our 8-inch with the 8-inch pipe obviously uses an 8-inch pipe connect, but that flow rate will nearly double. So if you're engineer working on these solar sites or data center sites or big industrial, automotive sites, we've seen basins with as many as 5 ponds. And so you can definitely save the contractor some effort and money by using the 8-inch max. And that's it. So anyone that would like a PDH certificate, please email us at info@rymarwaterworks.com. We'll be happy to send one to you. Those of you in Indiana, we are Indiana approved. If anyone else is out there in a state that requires approval for PDHs, let us know. I'm not aware of any, but we're happy to do that. Hopefully you agree that we're providing a good technical presentation today. And hopefully you found it worthwhile and interesting. So I did have one question in here. Said, are there any requirements or guidelines for assigning the invert elevation of the 4-inch rigid pipe at the connection to the outlet riser structure? So that invert needs to be, if it's a dry pond at the bottom of the pond, if it's got a permanent pool, just put that at whatever permanent pool it's going to be. It's going to stop flowing at, when it hits that invert. It's a gravity flow device, so it's not going to siphon. So hopefully that answers your question. If that doesn't, Brandon, please follow up question or shoot us an email. I'll be glad to answer that. Again, appreciate everybody joining us today. Ran just a couple of minutes over, but hopefully you found it worthwhile. I will end with this. If you like what you heard today, we would really appreciate you considering specifying the Marlee float on your next project. If you're an engineer that has an internal tool that you use to do your skimmers, let us know. And if it's based on a different skimmer, we're happy to take the time, adjust your tool to work with the Marlee float and give it back to you. We've done that for a couple of pretty large engineering companies. I'm not going to say their name, but they've been thrilled and they're using it, and it makes it super simple internally to get that done. We're happy to work with you however we can to make that happen. So, all right, I'm going to stop the share now. I'm also going to stop the recording.